Okay, hello class. This is the second Zoom session for the HMGT400. In this Zoom session, I received lots of questions regarding exercise 3. And exercise 3 is computing the ANOVA test for 3 group, including high competitive market, moderate competitive market, and low competitive market, based on the Herfindahl index for the hospital. Let me turn off this. And let me share my screen and then walk through this. Any of you try to submit exercise 3, but you have difficulties to compute that? No? Okay, that's good news. You know, the exercise 3 have 3 columns, 4 columns actually. The first column is a high competitive market. The second column is a moderate. The third column is a low competitive market. And I'm sure you know how to compute the N mean and the standard deviation. It's very similar to exercise 1 and 2. I'm not going to explain that. You know how to do that. You can use the count ifs comment for the N. You can use average ifs command for the mean, and you can use the standard deviation std.s for the standard deviation. And so the question is how to compute ANOVA using Excel. And usually most of you are going with pre-designed function in Excel, but the pre-designed function in Excel is most of the time is good whenever you have a wide data. As I explained in the other live session, the data in the class is a long data. And do you know the differences between long data and wide data, correct? Anyone want to explain that? No? Okay, I explain myself. You know, this is an example. If you consider you have data for 2011, let me go with the today example. You have the low market, and you have a low market, moderate market, you have a high. And then let's say this number repeated several times, and you have randomly some number here. Let's say 50, 60, 70, this is a random number, 10, 110, and 200. This is the long data. The long data is, there is a one variable to define the market, and the other variable is the observation for that specific row. Here I have 1 set of data, 2, and 3 observation for each market. And if I sort this, probably you can see this better. If I sort this, you see I have 3 observations for each market. This is long data. This is the class data. But if you like to use the ANOVA using the pre-designed function in Excel, you should have a wide data. The wide data is something like this. You have a bets for high. You have a bets for low. And you have a bets for moderate. And you have 3 observations for each. For the high, you have this 3 observation. For example, you have something like this. I'm just making some number. These are not a real number and not exactly following the left side. 6, and 20, 30. So this is the wide data. Whenever you have a wide data, you can use compare them together in the pre-designed ANOVA test. But if you have something like this, and you have to compute this for all of these variables, 14 different variables, and then the pre-developed function is not useful. It's useful, but you should work on the data. There's two options. The first option is to change the data to the wide. I do not recommend that. That's a lots of work, and it's going to create more confusion for you. The other option is to write a formula to compute the ANOVA. This is the ANOVA test. The ANOVA, this is the test for the ANOVA. This is it, right? You should compute the F value, and the F value is MSB divided by MSW. And MSB is a means for between group and within groups. So this is the formula. SSB is computing like sigma for all of the observation, and this is it. Final, this is the formula, right? This is this sigma xi for a specific group minus sigma xi as an individual level on power of 2, and you should merge them together. I mean, combine them together as a sigma. The same for within groups, and then when you have that one, you can subtract, or you can compute the first between and the total, and then subtract the within groups for the other side. So basically, if you have two of this, you can compute the last one. This is the way I'm going to compute this, providing an example for hospital beds. And then when you have this one, you can do it for yourself for the other part. First thing first, the data you have is in this format, right? This is the data set you have, right? I just don't need to see our entire data set, so I'm gonna just go ahead and mute this. Hopefully if I mute this, I have them, okay, I have my pre-developed. Okay, I have my pre-developed example here is this app here. Let me go close this. So I want to show you that this is the data you already have. This is the entire data. You don't have it. This is the data. Actually, I hide everything. This is the data set you have. But I'm going to show you only one example for the hospital beds. Let me close this because I saw that accidentally drop the formula. And this is it. I'm gonna share this file to the class, so you don't need to worry about this formula to write anything. And I'm also recording this video, so you can, after this Zoom, go ahead and back and check it again. So I'm gonna compute the ANOVA for comparing hospital beds between 3 different markets. So I should compute, I'm gonna go and compute SST and SSW. When I have these two, the SSB should be SST minus SSW, correct? Because this is the formula, right? SST equal to SSB plus SSW. And if I have two of them, I can compute the third one. First, so I'm just keeping everything I need. So I just need to have hospital bed, Herfindahl index, and the Herfindahl index, I have 1, 2, 3, and then every pace back to, let me see the definition for 1, 2, 3. Here in the RStudio code, there's a definition for this. 1, 2, 3. 0 high competitive, 1 moderate, and 2 low. 0 high, 1, 2, 1 moderate, 2 low. Okay. Here, first, I need to compute the means for all of the beds. The mean average mean for all of the beds is, you can compute this, right? Average for all of the hospital beds. Formula is average. I have here column G. Maybe you have a different, but the column is the hospital beds. So this is the average comment. And you should compute the average comment for high, moderate, and low. The high was 0. I'm using the average if comment. Same here. I'm filtering by 0, and then I can see high. The same for moderate, and the same for low. So next step. So this is the basic command I need here. The first, when I have this, I need to compute this value, SST. SST is equal to sigma of total average mean minus xi for each hospital. So for example here, this is the formula. X bar, usually we use the X bar for a mean, right? X bar for total minus xi as an individual level. So I have this on power of 2. See the formula on power of 2. And because it's on power of 2, it doesn't matter which of them is the first. I mean, it doesn't matter, you subtract the total from the I, from each individual, or the individual from the total. The formulas say xig minus x bar. So xig means xi, every individual observation for G as a group, in group 1, minus x bar of total T. See, let me give you the higher resolution. You can see this formula. This is xi, right? xig, it's a sigma of sigma for number of k as a group and as a number of observation. Xij, xi is back to xij, mean, for example, the hospital in the first high competitive market. Xt and t back to the total here, x bar. Whenever you see this sign, x bar does mean the mean average. Okay. And I will explain about the n minus I, n minus k, k minus 1 later. So here I'm computing this one, right? I'm going to show how to compute this one. I have the average mean here, and I have observation here. So I need to subtract this from this on power of 2. And because I want to keep everything at the same, I need to fix this line. And I'm suggesting you to use exactly the same formula because I will show you how to use for other variable using exactly the same format. You don't need to compute everything for all the variables. You can just write formula one time. It's really hot here. Let me turn it on. Okay. Sorry. Okay. So this is the formula. Let me give you the bigger screening. Hopefully you can see. I'm not able to see this. This is the formula, right? I'm computing, subtracting this from this. And as you see, I fixed this using the dollar sign for B. This is a B 3035. I fixed this dollar for B and dollar for 3035. It's used, if you copy this formula, any place will keep this 376. Yeah. And when you have this one, you can drag it here, click on this and drag it to the end. And then when you have this, you can compute the sum. This is the sum of all of this. The sum, if I do this, sum of all of this. Give me the same numbers here. So we repeat this for the other part. Let me give you this. for entire page. You can see everything. This is for total. This is for high. I repeat the same. In this time, I have to fix this one. $B $3037 minus G2. The G2 is this one. I do it for 1 and drag it to the end, and then compute the sum, right? No, this is the point. This is the sum for entire, right? This is the sum for every entire, but this is the high. I should use the sum if comment, sum if comment for this, sum this comment. I'm asking Stata to just compute everything for high competitive market. So you see I filter this by 0. This is sum if for this and give me this number. I'm repeating for moderate. This time I have to fix this. CS $B $3038 minus G2 is the G2, and then when I have this one, I can drag it and do this again, the sum if for this comment. This time I filter by 1 for the moderate. So let me add a 0 here, 1 here, and 2 for here, so you will not be confused. And finally, I should compute this one. Compute this, $B $3039, this is this line, and minus this. And then when you have this one, you can drag it and gain the sum if, and this time we should filter by number 2. So now I have, I needed this means to compute this one. So SST, this is SST. I just put them here. And SSW is the sum of all of this. SSW is the sum of all of this. I just computed them here. Plus this, plus this. Whenever I have these two, SSB should be SST minus SSW, right? I have this minus this, I have SST. Now I should go ahead with the denominator. The denominator is number of group is this one, K minus 1. K minus 1 is number of groups. So I have K minus 1 and I have 3 groups. I can get 2, right? 3 minus 1 give me 2. And the denominator is count of this minus 3. You know by default, if there is no missing, you expected to have 3030 observation. But I use the formula here, the count of this, because the reason is I want to use this formula to compute anything else. So I don't need to repeat everything for entire analysis. It is good if you want to learn, just do it for everything else. But so I will show you another way to do this easier. This is here. This is n minus k. This is this one. Degree of freedom for, we have 3000 observation minus 3027. And then this is MSB. The MSB is this thing. This number B3044 divided by this number, number 2. MSW, I have the same. I have MSW divided by denominator. Denominator is this one. Look at this different. This is W divided by this one. MSB denominator is back to this side of the formula. I use this as a denominator. I use MSW as a denominator. Denominator divided by degree of freedom for the group. And this is a Wheating group, so the denominator divided by entire observation. Degree of freedom is this. Degree of freedom for that is this. Or one of them is this, the other one is this. And then for the F, this is the formula for it. MSB divided by MSW. I have this and I have 24.6. Usually when you have F, if you estimate a 5% confidence interval, alpha or alpha, whenever we say alpha equal to 5%, I mean confidence interval equal to 1 minus 5%, right? It's gonna be 95%. And does mean with any situation like this, 95% of the time I expected to see exactly the same result. There's 5% that I don't see for any reason. Maybe that's incorrect number. So the error term is a 5%. Whenever you have, for the 5% error, you expect, if you want to see significant, your number should be between 1.96 minus 1.96 and 1.96. Any number bigger than 1.96 or smaller than 1.96 minus is not significant. Any other number is significant. So this is using the F-test to understand the significance. But if you like to do the p-value, this is the formula. F.dist RT, this one, you should go with this one and this one, 2 degree of freedom. You should include the degree of freedom for within groups and degree of freedom for between groups. This is the way you can compute the p-value for hospital beds. And let me give you an example for another. So you said this is the p-value. So this is the, let's go for the number of paid employers. Let's go with a different number, maybe something like hospital cost, for example. I like to give you the bigger number. Hospital cost is this one, right? Hospital beds, hospital capacity for the this. This is the hospital cost, right? I computed everything for hospital beds, correct class. But if I copy the hospital cost to hospital beds, this is not a standard way to do that, but this is the way, because whenever you have a fixed formula like this, you route this for the beds, and if you copy for this, the entire result should be for hospital cost. Basically, instead of changing the formula, I changed the data. I have the formula for hospital beds, so let me back to the original formula. This is it, right? If you copy this here, you can see the p-value for the hospital beds. Let's go back to this. If you give the total hospital revenue, give you anything for total hospital revenue. So basically, using this, the way I'm using, you don't need to write a formula for every piece. You just make sure to have one right formula and then compute the other parts. There's other point you need to consider. And the point is, the question asks you to compute hospital net benefit. You should compute the hospital net benefit. The hospital net benefit is subtracting hospital cost minus hospital revenue. So you should divide and subtract the hospital cost from hospital revenue to get the net benefit. And there's another way, and this is one of the variables you should create. The other variable you should create is Medicare and Medicare discharge, right? So you should go ahead here and let's see this and see this one. Okay, this is total hospital discharge. You know, you can compute this. Let me hide them here momentarily. To get Medicare, this variable, Medicare discharge, let's do this. The Medicare discharge should be, this is the Medicare discharge ratio, correct? The question asks the ratio or the Medicare discharge. Okay, the question never asked the discharge ratio, so then you don't need to compute this value. I was thinking on the other day for the, oh, this is for the next week, for the ratio. Let me explain that to you because you need that for exercise 4 also. For Medicare ratio, you should go with this approach. This is Medicare ratio, right? You have two variables here. That's for the exercise 4. Medicare discharge ratio. So you have, so let's see, this is total hospital ratio. This is total Medicare discharge. To Medicare discharge, you should divide Medicare discharge divided by total hospital discharge. Whenever you have one, you can drag it for the entire page. And for the Medicare, Medicaid, you should divide the Medicaid by total hospital discharge and drag it. So this is for the exercise 4 if you need. For this exercise, you just need to do it for one of the variables. And then the way I show you to do that, you can compute. Otherwise, you can do it manually for all of the other variables to make sure you learn this very well. Any questions so far for exercise 3?
Hi, I think that my only issue as far as copying and pasting, for instance, the Medicare ratio into the formula that you already created, I was having some errors and I wasn't sure if I was pasting it incorrectly. It was just an Excel thing that I was not getting correctly.
Okay, are you talking about, because I had difficult time to hear you, are you talking about exercise 4?
No, I'm talking about exercise 3. So when you're copying and
for the
pasting,
formula for the ANOVA test?
Yeah, so it looks like I have all the values correct, but so for hospital beds, for instance, it looks exactly as yours does, as well as everything else that you've done. But when I start copying and pasting something that I've had to calculate, I'm like, for instance, the total hospital benefit, I'm getting an error, and I'm thinking it's just something that I'm doing incorrectly.
Okay, let me go step by step for each question. For Medicare and Medicare discharge, let me try this to see what's the problem. I'm repeating here and I can get result. There's no problem with this. Maybe there's a problem. Let me try for the Medicaid. But I know what you're talking. You're talking about the benefit. The problem with benefit is, I see, okay, I see the problem. Let me go with benefit, because when you compute the benefit, there are some errors and some, okay, let me keep it here. I need that for the next exercise. For the benefit, let me go with this. Benefit. If you go to get benefit, you should subtract revenue from the cost. And I believe this is the cost, right? See, make sure. What is this? Did I remove this accidentally? We close this. Open it. So let's make sure I have hospital cost. Okay, this is hospital cost, this is hospital revenue. So let me do this. I think I computed here, benefits here. Okay, the way I did it here, I add one variable. Let me remove this one. And let me show you this. I'm gonna hide everything except this. So we have everything to see. Benefits. Revenue minus cost. And you should, okay, I see, in the video I explained to you, please compute the absolute value for benefits. Make sure to put ABS as absolute value for the benefit, otherwise the Excel gives you error for negative value and not able to compute the regression.
Okay, that might be it.
Yeah, also maybe I'm not sure about this data, but even if you have any error, let's try and filter this and make sure there is no error term this. If there is error in this data, because if any of these observation is missing, you will receive a signal like this. No, there is no signal. So let me show you an example. If any of them is missing, you are not able to compute. It's computing it now. Yeah, it's computing this. Now let's me back. Formula, what is this? This is nothing. Let me hide this. If I remove this, still can give me a result. If I remove this, okay, I see. If you go with absolute value, the problem will solve. So go with absolute value. And let me go ahead with the formula for this, with the example for exercise 4. Class, do you have any question for the exercise 3? No question? Okay, I assume there's no question. Hide. And for the exercise 4, for the Excel users, let's see, with the Excel user, this is it. Run a linear model and predict the differences between hospital bed and hospital net benefit in teaching the hospital. So there are 2 steps before you're going to get to the formula. The first step is creating the benefit. I explained that. The second part is to run a model only for teaching hospital. So the question, the question didn't ask for entire data. The question asked only for teaching. Let's go ahead and and this is the things I did. I had hospital beds. I need a ratio for Medicare, and that's it. I need 4 variables. Benefits. These are all the variables I need for this formula. For the regression, one moment, let me remove this. I should have benefits, absolute value. And this is the formula, right? Usually we say a formula like this. Beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus error term, right? Should be plus. Beta 3 x3 plus error, right? And the y here is a benefit, is absolute value for benefit. As a function of beta naught, you don't need that, so they are automatically be created. Beta 1 beds plus beta 2 Medicare ratio plus beta 3 Medicaid ratio plus error. Any package you are using computed the error term and beta naught. So the beta naught, you don't need to be worried about that, but you need to report the coefficient for beta for beds, Medicare and Medicare. So the question asks you for this coefficient, right? Coefficient for this. Okay, let's go with this. We have benefits. We should compute ratio Medicare. And we also need hospital beds. So the point about the Excel is you should have all of them in the order as I wrote the formula. The reason I wrote the formula here is because I want to show you should exactly have them as it is here. So you should have a benefit first, you should have a beds, you should have a Medicare. Let's see the question asks Medicare or Medicaid. Okay, Medicare and then Medicaid. You should exactly have the same as in the formula. If you go with this, the hospital beds, you can copy the hospital beds from here, and then you can paste everything this. For the Medicare discharge, you can get this. It was total hospital, it was, which of them was the first one? Okay. The Medicare discharge is this one, divided by total. And you can drag it to get everything. And for the Medicaid, you should go with this, divided by this one. You can drag it, and so these are the variable you need. Benefit, hospital beds, this one and this one. Then I'm gonna go with the last model only, because whenever I have it's very easy to get the other model. On the data analysis, the regression, I explained in the step-by-step guideline how to get this work. So if you don't have this package, and for the statistical part, you should install in your computer by just going in some option in the Excel. You don't need to purchase any package. I saw a few websites that they are selling those packages, so you don't need to get anything from them. Input Y range should be this one. Oh, the other part, so I need to go with that. We cancel this. You should also filter data by teaching. This is a teaching. So now, because I have copied everything here, I can hide them. I keep teaching here only. I'm gonna hide everything else and just stay with this small part. So you don't need to see everything here. So I have this teaching, and the teaching, you know, you should sort the data for teaching. Select this part. For now, I have a column. I probably in yours you have a column. The other column I don't know because I hide everything. And make sure to filter the data. Sort the data and then filter. So if you sort the data A to Z, the first one should be 0 is non-teaching and 1 is teaching. So you need to divide the data to two different parts. It's here, 0 is non-teaching, 1 is teaching. Let me divide them and then go back. Okay. This is this line, right? 206. You can show here for yourself, you can highlight. So then I have two parts of data. Hide this and hide this. And go up and down with holding shift and page up and down. Okay, now I have, this is the teaching. this is non-teaching, this is teaching, right? So, and I have the same value. You can add a copy, just the label of variables here. So to have the label for your data, for your codes, for your outputs. So now I have the data ready to analyze, and then I can, let me highlight this to make sure I can keep this. Clicking on the data analysis, regression. The range of regression should be this one. I'm going to select this hospital benefits. See, the range started from number 1 till 2095. The range for X variable, I'm going to include all of them for the last model. I should include hospital beds, Medicare and Medicare ratio for entire. So I'm including all of them, right? And the next thing I need to compute is the output range. The output range, the place you want to see the results. So usually you can go, for example, I'm going for this place, something like here, any place you can choose. For example, here. And I don't need to fix anything. I like to see confidence interval. I don't need to see anything else. That's it. And let's go for this. Non-numeric data. In some place, there is some, okay, let me go with this. I should start with line 2 probably to work on here. Let me try what time. With regression, select this, start from here to this. Second one, start from here. Oh, sorry, mistake. Next, I should go with benefit. Regression. I'm using this. I believe you can include the first line. If it didn't work, there's some missing in this data. We have to fix this. Okay, let's see the data. Maybe there's some problem in this data we need to fix. Here you go. This is the place I mentioned to you. There is a problem with this. You should impute them by missing, impute by 0. Otherwise, you're going to be, you can filter these two parts. This was the same problem you had, Jessica. You are not here. Let's sort this data filter. Click on the filter. Go down to find the signal that show you there is this variable in this data. You should remove them by 0. The same for here. Hopefully it worked now. Select all. Okay. Make sure there is nothing here. Just walking through this fast. And the way I wrote this class, it was for the RStudio. That's the reason when you work with RStudio will fix everything. For the Excel, you should do it manually. Okay, let's go and filter the data again. Okay, I have a filter for this. Okay, same here. Oh, we're gonna set this. Okay, now it's ready to get regression. Hopefully it worked this time. Okay, I have choose this one. Let me go with everything again. I should choose this one, hospital benefits. And I'm going to include this. Remove everything. Hospital beds entire. And I have the output range here. Okay, and hopefully it worked. Input range contain non-numeric number. There is some other problem. We should fix that. Let's see.
Professor, I think you have the column headers included in that data regression.
I believe it should work. I can try that because otherwise you're not able to see that. You can see if you got 2 is going to work. Oh, come on. It's 2 for here. Let me remove this. This is it. You mean I don't include this? Let's try this way. It's better to just go into data. Okay. That's all. Thank you. Yeah, that's the reason. The reason I include this because I want to see this one. So for now, you should copy from here. Can copy from here. It's the special volume transcript. This is this way. This is everything the question asks you is this one, right? This is the questions, coefficient, standard deviation. Should report everything on this. You have this one, right? Coefficient, standard error, t-test, p-value, lower, upper. So we should report this for hospital beds. This is the first one intercept. You don't need that. The hospital bed, Medicare and Medicare ratio. Can copy from here. Lower and upper. This is from this. And then question also ask ours. I think the Excel don't compute the R square, right? We should also report the R square for this. And the R square is this one. We should report this 0.05 for the formula. And then you can repeat the formula for the second set of this data. I believe we can include this. Let me try. This is for non-teaching. And this is for teaching. Let's see if I go with on this one, given smaller, higher. I'd like to try if I repeat the regression for the teaching. Gonna happen here. Okay. Let's include hospital bed for this time. If it didn't work, then we don't need to include that. And then include everything. Oh, mistake. The dependent variable is benefits. And this is benefits. And the place should be here. Okay. You are right. We don't need to include this either for this part. Okay, and this is for the second part of the model. You can just include this from this place, and the same for this one. Okay, this is for teaching, that one for non-teaching. And then for every single model, you should just, for example, the first model should include these two. The third model, second model, you should include, the first is teaching, the second is non-teaching, the third model is for entire for teaching and for non-teaching. This is for exercise 4, and the exercise 5 still is the same for the Excel users. because the Excel doesn't report the AIC, you can report the R square for this too. So this is the point to exercise 5. Okay, it was everything about the exercise 3, 4, and 5. Do you have any questions for the exercise?
I have a question. This is Sarah. For the data that you got on Excel, can you explain what a negative coefficient is? Like for the Medicare and Medicaid ratios,
yes,
they come up as negative. Can you just explain that to me, please?
Of course. You know, whenever you have a positive, so the formula shows the association between benefit and hospital beds, hospital Medicare ratio, and the hospital Medicaid ratio. So this is the formula, right? You have the benefit as a function of beds, Medicaid, Medicare, and Medicaid. So any negative, any positive sign in the right-hand side will increase the benefit. Any negative will reduce the benefit. This is a linear model, right? But also you should look at the p-value. If the p-value is significant, then you can say, okay, there is a positive or negative relationship. So look at the p-value for this. Let me go back to the numbers to make sure we have. So all of the p-value are okay, significant here, except the last one. The hospital beds is 700. So let me give you a smaller number. You can compute it. We can look at them very well. These are so confusing. Okay. So the intercept is $25 million. I mean, in any situation a hospital has, and the hospital in our sample has $25 million benefits without considering anything. But if you look at the hospital beds, you see every hospital bed increased. You expected to see increase in benefit. Look at C. The sign is up, right? Benefit increase, bed increase, benefit increase. Benefit up if bed is up. So let's go with bed. Medicare, Medicaid. Benefit here, right? So benefit, come on. Bed up, benefit up, right? Beds down, benefit down. Medicare up, so benefits up, positive. This is positive relationship between these two. I hate data, Excel. I'm sorry. The positive sign is this one. It does mean with 1 unit increase with hospital bed, you expected to have $7,000 benefit to the hospital. So based on this, and this is significant, right? And this is significant. P-value is less than 0.05. A bigger hospital has a higher benefit. Ratio for Medicare is a negative, so I mean with increasing number of Medicare ratio, 1% increase in Medicare, you expected to see minus $30 million lost in benefits. It is significant, but for the Medicaid, it is still negative, but it is not significant. I mean, in this sample, having higher Medicare patients will reduce the benefits, but having a higher Medicaid patient is negative impact, but doesn't significantly reduce the benefits. Any other questions, Sarah?
So basically, we would want Medicaid, not Medicare, because of the difference.
You want the Medicare. You don't. None of them is useful for benefiting the hospital based on the regression here.
Right. Okay. Okay, but if we had to choose between the two, we would want Medicaid over Medicare because
Yes, if
it's
you
less
have the
of a
choice,
benefit.
yes, that's exactly true. That's
Okay.
true.
All right, thank you.
Sure. Any other question, class? So, any question for individual assignment 2? The individual assignment 2 is very similar to individual assignment 1, right? So you already have my feedback on individual assignment 1, and except a few members of the class. So please review that carefully. For the individual assignment 2, I don't expect any kind of literate review, but you should have a main section, a method section, including hypothesis data, material variables. Please make sure to use the full the draft in the class. List of variables, discuss the method section, discuss the type of analysis you perform. I don't expect any more than the mean test. I mean, the t-test value will be based on the subject you have submitted. There is no more than t-test. For more, all of you have a descriptive analysis using a t-test. Please make sure to support your findings with at least one citation. And the results section, please discuss your findings. Please support your findings with a plot. Most of them are not using RStudio, but please support with kind of the bar chart. Even for two population, the pie chart is a good time. For example, the black and white, maybe the pie chart is a good chart. For two states, the bar chart is better because whenever you have a pie chart, you expect to see the same population. Black and white are the same population. For example, 70% increase in black will reduce. It should be 1 minus 7%, 30% in white, vice versa. Descriptive table, and then discussion. In the discussion, please discuss your thought, why you are thinking this is important, why your findings telling you what the other document telling you. It is good to support your document, your findings with at least one citation here. Make sure to add a limitation conclusion, not more than 2 or 3 lines for conclusion recommendation. Let's say one paragraph. One paragraph usually stands by 125 words. I'm not meaning to just to stay with this exact number, but I'm just giving you some estimate for the number of lines I expected to see for the conclusion and the references. And this is for individual assignment 2. And one last point for the RStudio users, please download the RStudio from the class, and then you should just copy everything in the right CAU and UC of your class, and then run the codes. If you run the codes, everything will be present here. You should just look at them and populate your tables using this. If you are using RStudio, you can see the density plot, so on the bar chart. So these are different type of the bar graph. The box plot, you can compare between high, moderate, and low. Based on this, you can see the moderate, the high has a more likely to have a more Medicaid ratio. So, and this is for exercise 3. And the density plot show that the cost and revenue always follow each other most of the time. And you see the blue line is over, then cost. Most of the hospital has a positive benefit, and based on the regression model we performed here, at least for non-teaching hospital, we have more than, so how many percentage is this? 2030, 68% of hospital at least has a $25 million benefit, and this is based on this figure. We can see most of the time, at least after this, the blue line is over the cost. It does mean there is a positive revenue for the hospitals. So I'm not explaining more on RStudio because there's no users in this session, but I'm available now for any other question if you have, class.
This is Sarah again. I have one question regarding assignment 2.
Yes.
So my method description in assignment 1 is very similar to assignment 2.
Mm-hmm.
Will we get dinged if we use the same for assignment 2 again, like for plagiarism? Or do I have to rewrite that whole section again?
No, not really.
Okay.
Not
Okay.
really. No, the main objective of this class is just to learn how to use the statistics. For that reason, for me, the analytical part is more important than the other part.
Okay. Thank you.
Please spend most of your time to describe your finding. As long as you know you have the same method section, that's fine with me.
Okay. Thank you.
You're welcome. Okay, any other questions? If not, thank you everyone for participating in the live session and enjoy the rest of your weekend.
Thank you.
You're welcome. Goodbye, everyone.
Thank you.
Thank
You're welcome. Thank you.
Thank you.
Goodbye, John. Okay, class, this is the end of live session. Goodbye, everyone.